Welcome back to Aurora Tech Channel. In this video, I will add some upgrades to the 2 Trees Sapphire Plus CoreXY printer. There has been a recent change in the price. The price of the printer was already pretty cheap, but I bought it for $375 from Banggood, and now it's only $330 from Aliexpress. 2 Trees is also selling an upgraded V1.1 version of this printer. The retail price of the new V1.1 is selling at $478, which is almost $150 more than this V1.0. It has 3 major upgrades. It upgraded from a sticker sheet print surface to a glass bed. It now uses 5 TMC2225 silent stepper drivers instead of 3 TMC2208, plus 2 A4988s. The TMC2225 is an upgraded version of the TMC2208, but it's not as good as the TMC2209, which can enable sensorless homing. The last upgrade was adding some LED lights. These upgrades are pretty nice, but I wouldn't pay an extra $150 for them. The V1.0 Sapphire Plus has firmware and quality issues, but we can fix all of them, so I still think $330 is an awesome deal. As long as the printer is still using the same motherboard and firmware, the issues are still here and still need to be fixed. In this video, I will add another 2 TMC2208 stepper drivers to replace the stock A4988 to make it a completely silent printer. I will also configure and compile the latest version of Marlin from scratch and replace the stock firmware. This also applies to other 3D printers. You can pretty much configure Marlin for all other printers using the instructions from this video. In my last video, I talked about the many minor issues in this printer. One of them is the auto bed leveling issue. Every time you set the correct Z offset value, the print is always off. It either prints in the air or crashes into the bed. You need to watch the first layer carefully and adjust the baby steps to make it work properly. After the Marlin firmware was installed, this issue was fixed. I will also show you how to enable the Auto Z Align feature in Marlin, since sometimes when we remove the print, clean the bed, or apply some pressure on one side of the bed for any reason, it will make the lead screws out of sync. If we do auto bed leveling with a tilted bed, it may still work, but obviously we don't want that. In this case, we will let Marlin align both sides automatically before each print. This may be the best way to fix this issue, so let's get started. I will start with designing a mount for the filament sensor. This printer came with a sensor, but it didn't have a mount. We will just make a simple design remixed with a cable clip. I will upload this file to Thingiverse. After the 3D printed mount is ready, we can simply put the sensor on the mount. The mount is a little too tight to fit in the V slot, so I will use a hot gun to soften it. Then, I will let the filament run through this sensor before it goes to the extruder. Finally, connect the cable to the sensor and the motherboard. You need to connect the cable to the MT-DET1 connector, which stands for Material Detector. Replacing the stepper drivers is pretty straightforward. You can get a set of 5 of these TMC2208s for less than $20. Since I already have some stepper drivers from an old motherboard which had a bad SD card slot, I will use them to save a few dollars. Just replace the old ones, align them, and follow the color of the connectors. One thing you need to know is that the direction of the TMC2208 steppers are inverted compared to the old A4988 drivers. We need to invert the direction of the stepper. We will do this when we configure the latest Marlin firmware. Now, let's download the latest firmware from marlinfw.org. This time, we don't need to download the sample config files, as there's nothing ready to use config for this Sapphire printer or the MKS Robin Nano V1.2 motherboard. This isn't a big deal. We can config it from scratch. After the download is complete, you can unzip the files. We may want to rename it as the printer's name for our own reference. Next, download Visual Studio Code to edit the firmware. I've already made a video about this for the Ender 5 Pro, but if you didn't watch that video, I will quickly go over this. After you installed VS Code, you need to add an extension called Platform IO. Click the extension icon and search for Platform IO IDE. Install it and you are all set. To configure a firmware from scratch, you need to edit two files. The configuration.h and configuration.adv.h. Let's start with configuration.h. I will go through this file and show you all the changes you need. These settings do not only apply to this printer. If you want to config any other printers, the process would be pretty much the same, but the parameters or values may be slightly different. First, we will set some basic information about the printer, like the ports, the motherboard, whether it has a heated bed, and the print volume. Search for Define Serial Port, or scroll down to around line 106. We need to define the serial ports on the motherboard. I get these values from the original 2-tree source code. Set the first serial port of this motherboard to 3. Set the second serial port to 1. This will allow the board to communicate with the bootloader, or when we connect the board to our computer using a program like Pronterface to collect data. Search for Define Motherboard, or scroll down a bit and you will see this line. We need to define what type of motherboard we are using. Select the board name, right-click and choose Go to Declarations. There is a long list of motherboards. The board that this printer is using is a MKS Robin Nano V1.2. Since there's no such motherboard, we will select the MKS Robin Nano, as this board is very similar to the Nano V1.2. Copy the name and paste it back to configuration.h. 3. This part is optional. Search for Define Custom Machine Name. We can give this printer a custom name, and this name will show up on the classic Marlin screen. For example, I will put Aurora CoreXY. 4. Search for Define Temp Sensor 0, or scroll down to around line 420. This part will define what kind of thermistor we use for the hot end and heated bed. Since we only have one hot end, we can set the value of the temp sensor 0 to 1, which is a 100K thermistor that is commonly used on most budget 3D printers like the Ender 3, the Ender 5, and this Sapphire Plus. If you upgrade it to an E3D V6, you may need to change it to 5. Just refer to the manufacturing manual and you should find the correct number. Next, we will set the heated bed thermistor. By default, it was disabled. A few years ago, not every budget 3D printer came with a heated bed, so in this case, we need to change temp sensor bed to 1. Since most printers also use the same 100K thermistor for the heated bed. 5. Search for Define CoreXY. If you use a Cartesian-style printer like an Ender 3, you don't have to enable this. As we are using a CoreXY printer, we need to uncomment and enable this line. 6. Search for Define X bed size. We also need to set the bed size. This bed size is 310 by 310. I would like to leave some margin, so I will set it to 305 by 305. For the Z max position, I found out that this printer can actually go above 350. If you use a sticker sheet print surface instead of a glass bed, you can go even further, but I won't change this value to above 350, so just set it to 350. 7. Search for Define Extruders. As this printer only has one extruder, the value should be 1. For now, I don't have a dual extruder printer, but if I have one in the future, I will show you how to set it up. The basic information part is done. Next, we will adjust some settings for end stops and stepper drivers. There are some common problems after users compile their own firmware. They may see that the motors are going in the wrong directions, the end stops aren't working like they're supposed to, or the printer is homing in the wrong directions. We will cover this one by one and explain them in detail. 1. Search for Define Use Xmin plug. Scroll down a little bit and you will see the end stop settings. You need to customize this part for most printers. In our case, this X limit switch or the end stop of the Sapphire Plus is on the left. This is our X-axis 0 position, which is also the minimum position, so this is a min plug. Most printers, including the Ender 3 and the CR10, all use Xmin plug by default. So we can uncomment Define Use Xmin plug. The Y is slightly different. For other Cartesian printers, when you home Y, it will move the bed up so it will hit the limit switch at the back. The print head is at the bottom of the bed, so this is Y min plug. But for this CoreXY printer, when you home the printer, it actually moves the print head to the top, so it will be at the maximum position. In this case, instead of Y min plug, we need to uncomment Use Y max plug. For the Z-axis, when we home a Cartesian printer, it will move the gantry down so the nozzle will be close to the print bed. When it reaches the lowest point, it will trigger the Z limit switch. This is the Z min plug. For this CoreXY, when we home it, it will move the bed up close to the nozzle. This is also a minimum position, so we will uncomment Use Z min plug. 2. Search for Define Xmin end stop inverting, or scroll down a little bit to around line 657. This will define how the end stops are connected. For our board, the ground and signal are inverted, so we will change inverting to true. We are not using both min and max stops for all axes. You can only change those that we are using, but I will simply change all of them to make sure I won't miss anything. Search for Define Min Software End Stops. This will restrict the movement of our X, Y, and Z axes according to the print bed size we set. So, If we want to move Z below 0 to set the Z offset, we need to disable this line. I will also disable the Max software end stop. 4. Search for Define X driver type or scroll down to line 680. This part will define the stepper drivers. By default, all steppers are set to the noisy A4988. Since the printer came with silent stepper drivers for the X, Y, and the extruder, we need to change it to TMC2208 standalone. As I also upgraded the Z axis to TMC2208, I will change Z driver and Z2 driver to TMC2208 standalone. 5. Search for Define Default Axis Steps per Unit, or scroll down to line 744. This will set the step for the motors. The X and Y are 80 steps, and the Z is 400 steps. This is the default value for most printers, including the Sapphire Plus. The extruder is a BMG clone, which uses a 3:1 gear ratio. From the 2trees config file, the number was 415 steps. This value works quite well, so I will still use 415 steps. 6. Search for Invert XDIR. We will set the direction of the stepper drivers. By default, the XYZ directions are set to false, true, false. If you're using the stock stepper drivers, which are 3 TMC2208s for the X, Y, and the extruder, and A4988 for the Z axis, you can set it to true, true, false. But since I upgraded the steppers for the Z axis, I will set all of them to true. For the extruder, the BMG clone extruder that came with this printer is also inverted, so we need to set Invert E0 direction to true as well. 7. Search for X Home DIR, or scroll down a little bit. You will see the home direction settings. We don't need to change X and Z, as we are using the minimum position, but we need to change Y from -1 to 1, as we are using the maximum position for the Y axis. Okay, the end stops and stepper drivers are now done. Next, we will enable some sensors. We have a filament runout sensor and a 3D touch, or a bltouch bed leveling sensor. 1. Search for Define Filament Runout Sensor. Simply enable this line. 2. Search for Define Nozzle Park feature. When the filament is running out, we want the nozzle to move away from our prints, so we can change the filament. There's another optional setting in the configuration adv.h file. I will talk about this later when we start to edit that file. For the bltouch or 3D touch, we also need to enable a few lines. 1. Search for Define bltouch. Enable this line. 2. Search for Define Nozzle to Probe Offset. In this part, we will define the distance between the sensor pin and the nozzle. You can use a ruler to measure it. The X position is pretty much in a straight line, so I will leave it as 0. For the Y, since it's about 45 millimeters in front of the nozzle, I will set it to -45. Leave the Z as 0. We can find the exact value when we turn on the printer using the paper test. 3. Search for Define Auto Bed Leveling Bilinear and enable this line. In this part, we will choose which type of bed leveling we want. The first 4 are auto bed leveling sensors, and the last one allows us to move the bed to different points to adjust the Z offset manually, so we can do mesh leveling for the whole print bed without a sensor. The first one with 3 points leveling is too simple. We may need more than 3 points to get a good result. The second one, linear, is using a line. We can define more than 3 points in one line, but sometimes it still may not be enough. The third one, bilinear, uses a grid. For example, a 5x5 has 25 points. Normally, 25 points is good enough for a 310 by 310 print bed, like the one with this printer. The last one, UBL, means Unified Bed Leveling, which allows us to fine-tune the area between the points of our grid. In this case, I will choose bilinear. 4. As we want to use a grid, we need to set how many points we will probe. Search for grid max points X. Set X to 5 and Y to 5 so we can probe 25 points on the bed. 5. Search for define Z safe homing. Enabling this line will allow us to probe the center of the bed when we do homing. 6. Search for define Z min probe uses Z min end stop pin. Make sure this line is enabled since we connected the black and white wire of the sensor to the Z min limit switch connector. 7. Search for define probing margin. The default value is 10, but if you use any clips to fix the glass bed, change the value to 20 to avoid probing on the clip or letting the cooling fan or other parts of the hot end touch the clip. 8. Search for define restore leveling after G28. We also want to enable restore leveling after G28. If this is enabled, every time after we auto-home the printer, it will recall the last saved leveling mesh data. Without this feature, we need to use M420S1 in the G-code of each file to do the same. There's another setting called baby stepping in configuration adv.h. We will take care of it later when we edit that file. Next, we will set up our touchscreen. 1. Search for MKS Robin TFT35. By default, it was set to TFT generic. You can see our screen, which is the Robin TFT 3.5 inch. Change TFT generic or simply add #define MKS Robin TFT35. 2. Next, scroll down a few lines. You can see there are 3 options for the TFT screen. The first one is TFT Classic UI, which means you will see the exact screen that is used on an LCD screen like the Ender 3. This option is not the most pretty one, but I prefer this UI since most of us are quite familiar with the classic LCD style menu. The second one is a TFT Color UI. This is a touchscreen version of the classic UI. You still get the same selections inside the menu, but it's now a touchscreen. The last one, TFT LVGL UI, is basically the same graphical UI that came with the printer. It still has some bugs. For example, I can't print G-code files inside folders. As long as you don't use folders, it should be fine. 3. Search for Define Touch Screen. Enable this line if you select the first or second option for Marlin UI in the last step. But you don't need to enable this line if you select the third option to use TFT LVGL UI. Okay, the screen is now done. Next, we will take a look at some speed, acceleration, and jerk settings. Search for Define Default Max Feed Rate. This line is set to the X, Y, Z, and the extruder default speed if we didn't specify the values in the printing G-code file. For now, I will just leave it at its default, since our slicer will set it for us. 2. Search for Define Default Max Acceleration. as this CoreXY printer with linear rails can move really quickly, I will leave it as 3000. Some printers may require you to slow it down to 1000, as the limitation of the hardware may not allow us to go that fast. If you want to print at 150 millimeters per second, you need at least 3000 or the firmware will slow it down. 3. Search for Define Classic Jerk. Normally, Marlin 2 uses junction deviation instead of jerk, which was used in Marlin 1. But, according to the config file that came with this printer, the manufacturer fine-tuned the jerk value. In this case, we will just use their values, which are 15, 15, and 0.3. 4. Search for Define Homing Feed Rate XY. We can leave the default as 50 times 60, which is 3000. For the Z feed rate, if you want a more accurate result with the 3D touch sensor, you can set it to be a bit slower, maybe 3 times 60, which is 180 millimeters per minute. Since by default, the leveling speed will also set it to the same as the homing speed. If you set this to 3 times 60, the probing speed of the sensor will also be the same. We are now basically done with the configuration.h file. There are also a few optional settings that I'd like to talk about. 1. Search for Define EEPROM Settings. By default, this is disabled, but I normally would enable it. If not, the Store Settings option will not show up on the LCD screen. Scroll down a bit to EEPROM Auto Init. I would also like to enable this line, since after we flash the firmware, sometimes the screen will show an EEPROM error. We need to manually go to the menu and select Restore Default Settings. Enabling this line will do that automatically. 3. Search for Preheat Constants. This part allows us to set default preheat temperatures for different materials. I normally print PLA at 205 degrees. If I use a sticker sheet print surface, I will set the bed temperature to 60 degrees. For thicker glass beds or other print surfaces that don't provide very good adhesion, I will set it to 70. I would also change ABS to PETG, since I print PETG more often than ABS. I will set the value to 240 and 90. 4. Finally, search for Define SDSUPPORT. Enable this line or your SD card slot won't work, unless you use other media to print. But in our case, this motherboard only has one SD card slot, so we will just enable this line. Okay, the configuration.h file is done. Save it and move to the next file. In this file, we will edit a few settings. We will set up the dual Z stepper drivers and auto-align them. We will edit baby stepping for real-time Z offset adjustment and the current for TMC stepper drivers. Select configuration adv.h. We just need to enable a few lines. 1. Search for Define num-Z stepper drivers. We have 2 stepper drivers for this board to control 2 Z motors independently. Other boards may only have 1 stepper driver with 2 connectors to control 2 motors, but in our case we have 2, so set it to 2. Search for Define Z Stepper Auto Align. This feature is very useful for this Sapphire Plus, since when we remove the print, we may apply some pressure to one side of the bed and move the motor out of sync. Enabling this option will allow us to put G34 in our starting G-code to align the Z-axis before we start the print. We can actually use G34 to replace G28 in our G-code. If the printer has not been auto-homed, it will also do auto-home for us. After this option is enabled, you will see a new option from the screen menu. Scroll down a little bit. We can set some values here. G34 max grade is to set the maximum incline that it can handle. You don't have to change it as a 5% incline is quite a lot. If the bed is tilted too much, we always want to adjust it manually first, or the pin of the sensor may not be long enough to handle that. Z-stepper align iterations means it will try to find how many rounds we need to sync the motors. Set Z-stepper align ACC to 0.01. This is the most accurate result we can get, as most stepper drivers and lead screws for budget 3D printers cannot turn to move less than 0.01 millimeters. 3. Search for Define Baby Stepping. We want to enable baby stepping so we can adjust the Z offset while printing. 4. Search for If Has Trinamic Config. This part is to define the current of the stepper motors. For TMC 2208 stepper drivers, we will leave the default current as 800. Normally, if you are still using the stock stepper motor, you should be fine with these settings. If you find that the stepper motor is getting hot or skipping steps, you may need to set it to a lower value like 650. Finally, search for Define Advanced Pause feature. We will also enable this setting. When the filament is running out, we want to pause the print so we can change the filament. That's all you need to do to configure Marlin from scratch to use for this printer. We can now save all files and then click on the alien head icon to compile the firmware. We need to select our board from the project tasks. Select MKS Robin Nano 35 and click Build. After a while, you will see this success message. Then go back to your Marlin folder, .pio subfolder, build MKS Robin Nano 35. For other boards, you can copy the firmware bin file to the root of your micro SD card. But for this board, the bootloader will only upload the file name robinnano35.bin, so copy this file to our SD card and turn on the printer. If everything is fine, you will see that the screen is showing the updating progress. After it's done, you will see the Marlin screen. It looks exactly like the classic LCD screen. The only difference is that we can use a button to control the menu instead of a knob. You can also click on the item to select it and press the Enter button on the screen to confirm. You can try other UI if you like, but I'll stick to this classic Marlin UI as it runs smoothly and allows me to access most features from Marlin. After I uploaded the latest version of Marlin to this printer, the bed leveling issue I mentioned in the last video was fixed. I'm not sure which part went wrong with the stock firmware, but I'm not going to dive any deeper since my goal is to make this printer work, and I'm quite happy with the result. It prints very quickly. I can print at 150 millimeters per second with pretty good quality. After enabling the Auto Z alignment feature in Marlin, I don't have to worry about one side of the bed dropping when I remove the print or clean the bed. You just need to change the G28 to G34 in your existing G-code files, or do that in the starting G-code of your slicer. It will automatically align the Z motors before doing auto bed leveling. I have also installed the sticker print surface that came with the printer. It sticks really well and the surface is very flat. As you can see, the prints that come from it all have a flat bottom. The stock stepper drivers for the Z-axis were very noisy, but after I upgraded them to the TMC 2208, they're almost silent. The only sound I can hear is the click from the bltouch and the wind from the fan inside the base. Spending a few dollars to upgrade the stepper drivers has made a huge difference. I have also replaced the bent lead screw on the left, and I put the Z lead screws mount on. After all these upgrades and fixes, I would say this printer is printing as well as all my other printers. It also prints faster. With the latest Marlin firmware and the classic LCD style UI, it works flawlessly. It requires a lot of work, but I am very happy with the result. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week.